Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Salicylic acid is to hydroxybenzoic acid. The hydroxyl OH group is a powerful ortho-para director and strongly activates the ring toward electrophilic aromatic substitution. The CU group is a deactivator meta-director. When salicylic acid reacts with excess bromine water, two things happen. 1. The OH group directs bromine to the ortho and para positions relative to itself. And 2. Under the conditions of excess bromine water, aqueous, relatively mild, the CU group undergoes decarboxylation because the phenol formed after tribromination is highly activated and the carboxylate is lost, similar to how 2,4,6-tribromophenol precipitates in the bromine water test for phenol. Moving on to the next step. In salicylic acid, OH-C1 CuO-C2 by conventional phenol numbering or OH-C2 CuO-C1 by carboxylic acid numbering, the OH group strongly activates the ring and directs to ortho and para positions relative to itself. Moving on to the next step. Bromine water, aqueous bromine, is used, which is the classic reagent for phenols. The OH group directs Br to positions ortho and para to it. Since CU already occupies one ortho position, bromination occurs at the remaining ortho position and the para position relative to OH. With excess bromine, all available activated positions get brominated. And for the final step. With excess bromine water, the intermediate tribrominated salicylic acid undergoes decarboxylation, loss of CO2, because the highly electron-rich tribromophenol ring facilitates this process. This is well known. Bromine water with salicylic acid gives 2,4,6-tribromophenol as the final product. 2,4,6-tribromophenol has OH at C1 Br at C2 Br at C4 Br at C6. This matches option C, which shows a benzene ring with OH at one position and Br at both ortho positions and the para position, 3 Br atoms total. With no CU group, decarboxylation has occurred. Why other options fail? Option A. Only one Br, incomplete reaction with excess bromine, and CU retained, incorrect for excess bromine water conditions. Option B. 2 Br atoms with CU retained, still incomplete bromination and no decarboxylation. Option D. 3 Br atoms, but CU retained and wrong positions, decarboxylation does not occur here, and the regiochemistry shown does not match expected ortho-para directing of OH. Option C correctly represents 2,4,6-tribromophenol, the product of electrophilic aromatic substitution at all three positions activated by OH, followed by decarboxylation. Therefore, the correct answer is C. Therefore, the correct answer is option C.